Welcome back. This is an Aleks training video on predicting the arrangement of electron groups around a central atom of a molecule. So if you have a molecule, there's going to be a shape of that molecule, and you can actually make some guesses as to what that shape will be based upon what is in it and how many things are attached to what, how electronegative or positive something is. You can make some guesses of exactly what that molecule is going to look like, even though you can't see it. So they're going to give us a nice hard one here, tellurium hexoxide. All right, so tellurium, I have to look that up. I don't even know where tellurium is. Let me look at the periodic table. You should always have a periodic table. Tellurium is in group 6, okay, and tellurium is in period 5. So the reason why I looked at period 5 is because I see that there are 6 oxygens, and my guess is that the tellurium is the center and that 6 oxygen groups are attaching to it. Now each of those bonds have 2 electrons in it. So 6 times 2 is 12. That means that this tellurium is going to be in the middle, and there are going to be 12 valence electrons. Well, you're only supposed to have 8. But in this case, it's so big, it's in group what, 5 or 6? Yeah, tellurium is group 5. It's big enough that it has some space that it can fit more than 8 valence electrons in it. Now, it's breaking the octet rule, but it does work. Okay, so since it works, what does it look like? All right, so let's take it this way. I'm just going to put tellurium in the middle, and I'm going to do a quick Lewis dot structure. So tellurium is in group 6, so it has 6. Oxygen is in group 6, so it has 6. Okay, so this is 7 times 6. Okay, that's 42, and this is got a -6 charge. So 42 plus 6 is 48. So how many pairs is that? That's 24 pairs. All right, so if there's 24 pairs, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6. Okay. That means I've got 18 more, right? 3, 6, 9, 12, 15, 18. That's nice. Okay. Now the whole thing is got a charge. So it's a -6. So there's your Lewis dot structure of it. So this has got 6 things attached to it. Well, I've given you a schematic here on the left. If you have 2 things attached to the central atom, the central atom is red in all these examples here. If I have 2 things attached to the central atom, they're both negative. They've got electrons on them, and those electrons want to repel each other. So the theory here is that these electrons, since they want to get away from each other, will go as far away as they're allowed to go. So if you have 2 things, the farthest they can go from each other is 180 degrees, and that's called linear. It looks like a straight line. Okay, you've got 2 or 3 or 4 or whatever in a straight row. If you've got 3 around the central atom, the farthest they can get around is 120 degrees. It would be like taking a circle and dividing it by 3. They want to get away 120 degrees from each other, and they're going to be planar. It'll be in the plane. It'll be like that they could sit on the table, okay, because that's as far away as they can get. If you've got 4, they're going to form a tetrahedral, which is like a 3-sided, it's actually 4-sided, but one's the bottom, pyramid with 3 visible sides. Okay, that is a tetrahedral. So you have a triangle on this side, triangle on this side, one on the back, and one on the bottom. So a tetrahedral has 4 things attached to the central atom on the inside, and its spaces, all of these spaces are equal at 109.5. That's as far as they can get away. So they'll go to that whatever they'll get away, that's how far they go. If you have 5, okay, the only way you can do 5 is to have 120 degrees at the equator and then 90 degrees at the poles. Okay, that's called triagonal bipyramidal. Okay, so because there's 2 pyramids, one inverted on top of the other. Then the last, if there's 6 things attached to the central atom, the farthest it can get away is 90 degrees from each other, all the things. So you've got a north, south, east, and west, and then you've got a straight up and a straight down. So that's 6. And its shape is called octahedral. So here I've got 6. 1, 2, 3, 4, 5, 6. So it's going to be octahedral. I can tell what its shape is going to be. And then how many electron groups are around the central atom. Well, remember, an electron group can either be a lone pair, that's an electron group, a single bond, that's an electron group, a double bond or a triple bond, that's an electron group. So how many electron groups? 1, 2, 3, 4, 5, 6. There are 6. Okay, so to do this question, they're going to ask how many electron groups do you have? Okay, around the central atom, there's 6. And then you can scroll down. What is its shape? It's going to be octahedral. And that's its shape. Okay? Hope I'm helping you.